Hello. I think we're live and good. Yep, looks like it. Welcome everyone. Back for another day of Advent of Code. There. Yeah, so back again today with another Advent of Code. Haven't looked at it yet. Haven't seen anyone talking about it yet. I haven't started anything as usual. So yeah, it looks like we're heading up to this island instead of this island after the detour we took on day 12. So let's have a look here. Day 13, shuttle search. Your ferry can make it safely to a nearby port, but it won't get much further. When you call to book another ship, you discover that no ships embark from that port to your vacation island. Wait, what? So there's no ships from here to here. Where else would they go? Anyways, that no ships embark from that port to your vacation island, you'll need to get from the port to the nearest airport. Fortunately, a shuttle bus service is available to bring you from the seaport to the airport. Each bus has an ID number that also indicates how often the bus leaves for the airport. Bus schedules are defined based on a timestamp that measures the number of minutes since some fixed reference point in the past. Okay. At timestamp 0, every bus simultaneously departed from the seaport. After that, each bus travels to the airport, then various other locations, and finally returns to the seaport to repeat its journey forever. The time this loop takes, a particular bus is also its ID number. The bus with ID 5 departs from the seaport at timestamps 0, 5, 10, 15, and so on. The bus with ID 11 departs at 0, 11, 22, 33, and so on. If you are there when the bus departs, you can ride that bus to the airport. Your notes, so my puzzle input, consists of 2 lines. The first line is your estimate of the earliest timestamp you could depart on a bus. Okay. The second line lists the bus IDs that are in service according to the shuttle company. Entries that show X must be out of service, so you decide to ignore them. To save time once you arrive, your goal is to figure out the earliest bus you can take to the airport. There will be exactly one such bus. For example, suppose you have the following notes. Hence, the earliest timestamp you could depart is 9:39. And the bus IDs in service are 7, 13, 59, 31, and 19. Near timestamp 931, these bus IDs depart at the times marked D. Right. So these depart at these times. Near timestamp, so this is no one leaves at this timestamp. The first one after is bus 59. The earliest bus you could take is bus ID 59. It doesn't depart until timestamp 944, so you would need to wait 5 minutes before it departs. Multiplying the bus ID by the number of minutes you need to wait gives 295. What is the ID of the earliest bus you can take to the airport multiplied by the number of minutes you'll need to wait for that bus? Okay, interesting. Right. So earliest timestamp. This is pretty small for you. Earliest timestamp and all of these should be simple enough to parse. Let me save that into our day 13 folder. There we go. And let me also just copy this example because we know sort of the values for this one, so it's easier to test against when we're writing our code. I mean, we probably need secutils and stereoutils again, and let us parse in. So we can split this in lines. Is there a, well, yeah, sure. So lines, let's just call this notes, because apparently these are the notes that we've taken. And for now, I'm going to be using this. Split that into lines. Let's put this on a new line like that. So yeah, earliest departure is the first node parsed as an integer, and the buses is the second line split on a comma, and there's no space after the comma, it's just the comma character. Filter, so if it is not equal to x. So basically what filter does, it checks this for everything in the sequence and only keeps the ones that are there, or where this holds true. So that should filter out all of the x's. And then we can map parse int over that. So now we just have all the buses as a list of integers. Right. So these all, so they start at 0 and they go up to this timestamp. So this is the earliest departure. We can make this a let actually, and then we can create our earliest bus and just set that to the highest value of an integer. And then for bus in buses, and let's do a departure is at 0. So while departure is smaller than, or smaller than earliest departure, then we add the number of the bus to the departure. So we start at 0, then we add the number. So we create all of these timestamp, basically. Create all of the timestamps until we create one that is larger than the earliest time that we can leave. And then we check if the earliest departure wait, we need to store the bus ID as well. If the earliest departure, no, if the earliest bus, actually we can, yeah. So if this departure is before the earliest currently known bus, then we set bus ID to be equal to bus, and we say that the earliest bus is this one. So I will just loop through all of them, find the earliest one, and print that out for us. And then what the output was, the amount of time we need to wait by the bus ID. So our earliest departure minus our earliest bus. This should always be positive because it's higher than earliest bus has to be larger or equal to earliest departure. And times that by the bus ID. How do you write buses? Is that 1 or 2 S's? Well, that wasn't very useful. Yeah, it's singular. Single S. Okay. So this one is wrong. There we go. MCR part 1. Minus 295. I mean, it's right, but the sign is wrong. So I probably, yeah. The part where I said that this is always positive, I had the order the wrong way around, so it was always negative. Departure. There we go. Okay, so now we can, instead of that, say that our nodes is equal to just 2 sequence lines of our input. Here we go. And that gives us 296, which was suspiciously similar to this one. So for a second there I was like, wait, did we mess this up? Right. So that was pretty simple. I'm curious about what part 2 is going to be. I have a feeling that it will be significantly harder. Or maybe they're nice with us since it's Sunday. Right. The shuttle company is running a contest. 1 gold coin for anyone that can find the earliest timestamp such that the first bus ID departs at that time. Wait, what? 1 gold coin for anyone that can find the earliest timestamp such that the first bus ID departs at that time, and each subsequent listed bus ID departs at that subsequent minute. So the first line in my input is no longer relevant. For example, suppose you have the same list of bus IDs as above, and X in the schedule means there are no constraints on what bus IDs must depart at that time. The second private leaderboard? Is there a second private leaderboard? I only know about the one I'm in. Oops. I only know about this one. Is this not the one I'm supposed to be in? I mean, as I'm waiting every day to solve them live on stream, it's not like I'm trying to be on top of the leaderboard anyways. Right. So an X in the schedule means there are no constraints on what bus IDs must depart at that time. Oh, they can get full. Right. And they carry, as far as I know, they carry over from 1 year to the next. So some of the people in the NIM, sort of the NIM leaderboard, isn't solving theirs in NIM. But they did maybe at some point in the past. I don't know. So I guess it makes sense to create a new one every year, I guess. Right. So an X in the schedule means there are no constraints on what bus IDs must depart at that time. Right, okay, so they mean something different now. This means you are looking for the earliest timestamp, called T, such that bus ID 7 departs at timestamp T. Bus ID 13 departs 1 minute. 1 minute after timestamp T. Oh, in order, right. There are no requirements or restrictions on departures at 2 or 3 minutes, because these are X's. Bus ID 59 departs 4 minutes after timestamp T. Yeah, so 1, 2, 3, 4. There's no on 5, 6, and 7. Right. The only bus departures that matter are the listed bus IDs at their specific offsets from T. Those bus IDs can depart at other times, and other bus IDs can depart at those times. What? Those bus IDs can depart at other times, and other bus IDs can depart at those times. For example, in the list above, because bus ID 19 must depart 7 minutes after the timestamp at which bus ID 7 departs, bus ID will also be departing with bus ID 19 at 7 minutes. Ah, right, yeah, but that doesn't matter. In this example, the earliest timestamp at which this occurs is this one, where they sort of line up. In the above example, bus ID 7 departs at timestamp blah 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 7 minutes after T. This is fine. The only requirement on that minute is that bus ID 19 departs then, and it does. Here are some other examples. So you had multiple tests. However, with so many bus IDs in your list, surely the actual earliest timestamp will be larger than a very big number. What is the earliest timestamp such that all of the listed bus IDs depart at offsets matching their positions in the list? Right. Yeah. I'm just reading IRC here. Someone said that the idea of the second leaderboard was to allow for other people to be in the leaderboard when the main one was full. Also, since main one has lots of people who joined in the past, as I said, and they're not doing this year in NIM. The new leaderboard is specific to those doing 2020 in NIM. Right. Cool. Right. Puzzle input is still the same as always. But line 0 doesn't really matter anymore. We can also grab this, grab these tests again. I mean, I'm tempted to just write this sort of by trial and error, like by going through them. But that will be a lot of iterations. But the math is pretty simple. And I mean, computers are fast, right? So let's just try that. We don't need to grab this earliest departure anymore. We can't filter out these. So our mapping, but we do want to have them parsed. So I'm gonna do a map it and say if it is equal to an x, then just return 0. Otherwise, parse it as an int. So now we know that x's are zeros. We can remove those, but we do need our timestamp set. And then, so for each of the buses, so we go through the buses. Let's take the index as well. The timestamp must be such that the first one strikes that timestamp. So we can go, actually we can increase, what we can do, we can do a for time in count up from 0 to int.high at an interval of our first bus. And I'm just going to double check that. Let's see. Day 13 input. Right, yeah. Our first one is not 0. Oops, I don't want to quit Vim. None of the tests have it either. I'm not sure if that's a rule or whatever, but this would just infinitely loop if the first one is 0. I mean, I guess we could do this. That way we know it's safe. Not that it matters for us or for any of the test cases, but now it's correct, not just happens to work. Right. So we don't really need to check the first one because that's the one we're using to count up. So we can go from the second bus. Actually, I think this creates a copy of the sequence, so that might actually be slower because we need that copy. Like we copy the data, which might be slower than what we're doing. I really wish there was a way to iterate over part of a sequence without creating a new sequence and without just iterating over the range and picking out the element in the sequence. I feel like that should be something you could do in one line. And it wouldn't be too hard to write an iterator like that, I don't think. Right. First timestamp. So we want to make sure that the time divided by the bus, actually time mod bus must be equal to 0. If it's not 0, we break. And this should of course be not only time but time plus I. And we break out of this loop. That should work, right? So time plus I is the time at which this bus should leave. Mod bus. What we should do here is to check that if bus is 0, then just carry on the loop. So these are the x's. So if you find an x, we just carry on with the loop. Yeah, if time plus 1 mod bus is not 0, so basically if this isn't divisible by the bus, that means that the bus doesn't leave at this time. Oh, I got another spammer in my channel. Interesting. I can ban him. One message was deleted. Right. So this should work, right? And we just echo out our timestamp. Timestamp equals time. Break the loop. This needs to go in a block called time loop. Let's wait. Is that how that song goes from Rocky Horror Picture Show? Let's do the time loop again, or something. Anyways, break out of the time loop. So basically, if we find this time plus I, if it's not the correct bus, we break out of this loop. So we just carry on ticking, and we don't set our timestamp. We could also just echo it out here and quit instead of doing this. But this is a bit nicer. Let's just do let's try this with one of the examples. Let's do this one. I mean, this might be so slow that it won't run to completion. I mean, not for this one, but for our input. Oh wow, yeah, it probably is. Wait. That felt like it took a bit too long. Echo out the time here. What was this supposed to be? 1 million. Yeah, we're way past that. Let's just do if time is larger than this, just break. Echo out the time actually. It takes a while to get there. Yeah, so it does get there. That means our logic is wrong. We can check, echo out the bus. Don't do that. And in this, if time is equal to the final timestamp, then echo out this bus. You know what? Let me just pop this in there as well. So just run this for one iteration. What? Oh. 713 0059 031 19. Which are all the buses. If it's 0, we should just continue. And it never breaks. Oh, does this break the... Yeah, this break now breaks the time loop. Right. So if we just here echo out the timestamp and quit instead, like I said we could, echo out the time. I mean, it's a bit ugly, but should at least work. There. So now if we just do this, go back to having 0. There. That now worked. It wasn't terribly slow either. That's actually quite fast. I mean, this is not even in release mode. Oh, it's not super quick. So I'm curious to see if it'll work with our input or not. But yeah, that gives the right value for that one. Let's just quickly try the other tests as well. Especially curious about the last one because it has a pretty high value. 3417. That's good. I'm guessing all of these will be like, I'm pretty sure we got the logic right, so 754018. Yep. I'm actually just gonna jump straight to this one, which is, as you can see, is gonna be pretty big. I mean, if this takes horribly long, then our actual input is gonna be way longer. Yeah, this does take quite a while. Oh yeah. Yeah, so we can't do this on our input. That would just run forever probably. 486. We got the correct answer, but I could set it to run and then leave and do something else for a couple of hours. Might finish. Okay, not great. This means that we need a better algorithm than just checking all of them. So what we're doing now, we're basically just going down for every departure of bus 7 and just checking these. But there must be a better way of doing it. We want to get this timestamp from all of those numbers. Well, I'm a bit busy at the moment. Test suite for binary parse. That actually looks pretty good. I'm assuming he doesn't watch this stream though. Let me just reply to him real quick. Right. So there must be some logic here that we can apply that will make this run faster. Or not run faster, like this is since these are completely independent, it would be easy to just like multi-thread the thing. But that's not really solving the problem in a better way. That's just throwing more compute power at it. So basically we're looking to align these. And they're all, we're trying to basically find a factor of these timestamps. Find a number. We want to know if this is a factor of this. Or we don't want to do that because that would mean going through this. Not really seeing that. There is some. Hey, thank you. He said enjoy AoC, which I'm not currently doing. I don't like these math puzzly things. So we check all the buses. We go through the time. So the slow part now is that we check every single one. Which obviously isn't great. One optimization would be to grab the highest timestamp. That would mean checking fewer numbers at least. But that again is just an optimization. So like right now we increment in steps of 17, but we could increment in steps of 971 instead. And sort of do just like check both ways out from that instead of checking only this way from this number. Is that a good path? What about the two highest? Oh. So if we take the two highest ones, we know the distance these two must be apart. So we can find their common. Oh, there's a gnat here. I have gotten some plant that from somewhere that has a lot of gnats in it, and it's annoying the shit out of me. They're everywhere now. Yeah. So what you're saying is that if we find sort of the common the point at which these step in unison, is that just a common factor between them? While I think about this, let me just code up find the highest number. Well, in this one actually won't get much faster because of it. Because this one isn't all that much bigger than this one. So this example actually won't get that much faster. Let's see. Oh, right now I'm just Googling something off screen here. We need to find where these two go in step, basically. So let's just do highest. is buses dot fold right or fold left. It doesn't really matter. I don't quite remember how this one works. Fold left. Template to fold the sequence from left to right. Returning the accumulation. I basically just want to get the highest one. So we can do fold left max A B. But the second highest. Max A B and second. But the smallest of these two. Oh no, that would still be the highest, right? Yep. I want the biggest number after I've subtracted highest. Would that work? I'm a bit tired today, so now I'm just basically guessing. Oh. Right, let's see. Isn't there a... No, of course there isn't. Picking the highest one shouldn't be the hard part of this, I realize. You know what? Fuck it. This is not the slow part. There. This works. So now I get this highest and the second highest. I need to find the point where they go in step and their step length. So I need to find the interval. Wait. Does that even make sense? Is there a set interval? I guess there might not be. Let me do something here. I'm just curious, and I'm too tired to figure it out in my head. So to count up by the highest, I mean, we're just gonna cheat here because it doesn't really matter. It's -2. So if I -2 mod the second highest is not equal to 0, just continue the loop. Otherwise I want to echo out I. Actually, I want to. Right. So this is a set interval, it seems. By the way, I'm scrolling up right now. As you can see. Come on. Okay, I'm gonna run this and quickly shut it off. It prints so much. There. Yeah, so I printed out these ones. I'm guessing that's just the first, because the first one is set to be 0. And then it goes all of these. Right. So it does have a step length. It appears. Sorry if I have thrown you off my path. You might want to continue with your reasoning. Well, I didn't really have a reasoning until you suggested something good. One good thing, though, would be to put the input in better shape. You only care about buses with the X, and the position is only useful to get the time delta, which you do not have to compute at every step, every time in the loop. Right, because I have quite a lot of X's. So you basically want me to go through and filter this into a list with IDs and positions instead of doing this this part of the loop to get the I's. Time delta. That is true. I mean, would save a little bit, I guess. Not on this example again, because there's only four numbers here, but okay, so let's just keep that around. And let's massage our data set a bit here as we have our let's call it just delta buses. This is a sequence of tuples from what? Then what I mean about the two highest, it was not even really about the two highest. It's about the fact that we're taking some steps according to your first bus. Then when you find a time that goes well with 2 buses, what can you do to take bigger steps for the rest of the buses? Oh. Now I see what you mean. Basically what I'm doing here, what I'm doing there is I'm finding this stepping difference. So I know that these buses must be this step length apart. So if I go through and find, okay, so this one and this one has some internal or some mutual step length, then I can start going by that step every time until I find check later how it went. Yeah, then I find a multiplicative of those in which this one is in step, and then I step by that until I find where this locks in, and then I have all of them. That is super clever, actually. Okay, so we don't really care if it's the highest or the second highest. Okay, wait. Let's first massage the data into something more useful. Index is an int, and the just the bus number is also an int. And then for bus in for I bus in buses, if actually let's do, instead of doing this, I think oops, just do that. Yeah, so delta buses for I bus in buses. If bus is equal to this, then if it's not equal to this, then delta buses that add the index and parse int of the bus. Note here that I have a space between add and this, which means that this is a tuple. Like this wouldn't work because now I'm calling add with 3 arguments with delta buses I and the value of this. Now I'm calling add with 2 arguments, delta buses, and this tuple. It's a tiny weird gotcha in them. Oh shit, I have to go soon. I have to be in a dinner in half an hour. I can drive there. So we have to do this really quick. I'm probably not going to be able to make it in time. I didn't think this was going to take so long. Let's see. Oops. Delta buses for those. We don't really care about the highest and second highest. So step is 1. While true for now, or current bus is also 0. That's an index. Well, current bus is not buses. Delta bus is not high. Oh, my head hurts. For multiple reasons. Go up by step. And we know that the last buses will all be locked in because our step is now, we know that they step in unison. So for I in count up, by step, if delta buses current bus dot index, so if this time minus that mod the current step wait, is all wait. Wait. We go up by step and we check if the timestamp plus this index is a modulo if this is divisible by the current bus's bus number, then this is so not working. Wait. We count up. So at least we need to increase this current bus. We also need to change the step to something. Okay, so let's think this through. We start with 1. We can actually start with current bus 0 dot bus. So in this case, we start with 1789, which is basically what we're doing here. But I mean, we start with this, doesn't matter. Then we loop through for our other bus, so the second highest, which is basically what this loop does for us. We check the different buses, and then we check if the index of the timestamp plus the index difference of the next bus. Should this be the difference from the beginning? No, this should be the difference from the last one, right? This has to be 1. If I plus delta buses modulo the bus that we're checking against is 0, then we increase the current bus number, and the new stepping distance is this thing. Which is I minus the step. Again, this is so not gonna work. Oh, this is not current bus, this is delta buses. Like, what are step distance? Oop. index 4 is not in 3. Wait, where? Line 20. Well, current bus is smaller than the highest one. What? Current bus starts at 1. It goes up. Oh, right. This needs to break out of this loop to get out to the while loop part. 1259. What was the solution to that one? Yeah, it's not that. As I said, this is not going to work. Echo out all of these sub steps. I'm just curious. Did we just not go far enough? I mean, now we're at least closer, like in a closer ballpark. So yeah, first our step is equal to the first one. What was this this one? I'm curious if we will find that if we only have those as options. $307. No, we find a different number. So our logic is flawed. Which I was pretty sure of, to be honest. Oh shit, I really need to go. Try and count up a step. Which is this thing, basically. I plus equal delta bus is current bus dot index, which is this. So this should be at offset 0, this should be at offset 1. So if this timestamp plus 1 mod this is 0, means it's divisible. Increase the current bus. We set step to be. Is it just this logic that's broken? What I here? What is I? This was higher, right? Yeah. Quite a bit higher, actually. So here we go through all timestamps in increments of this, which is basically what we're doing here. Check if the timestamp of the other one falls on an interval of it. Wait, we were doing basically the opposite, or the other way around. I mean, the their common like stepping thing should be the same, right? So we're obviously doing something wrong here. Oh wait, but they had to be 2 apart earlier. Yeah, so this won't give me the same number. There. I mean, I think we're onto something, and it really annoys me because now I really have to go. Is it something as simple as just like setting step to I or something, and we have it? No. This was annoying. Is it something like this? I'm basically just blindly guessing at the moment. No. Oh, that was actually... Wait, what? Oh, it's because we increase current bus before we do that. No. Oh, that's annoying. So you need this to be smaller. It's not just that, right? Oop, that seemed to have made it negative or something. Anyways, I really have to run. I think we're onto something. It's if I figure out the logic there, it will probably work. But I really need to run now, and it annoys the shit out of me. But yeah. That's annoying. Okay. Anyways, goodbye everyone. I hope you have continue to have a nice Advent, and that you are having fun with the AoC Advent calendar. Wait, it's a special day. It's like Saint Lucia's Day. Is that what you call it in English? So happy that if you celebrate that. We kind of do here in Norway. We have a tradition of eating like this thing. Like it's like a bun but with saffron to make them yellow for some reason. They're pretty good. Is this saffron bun? Cornish tea treat. Yeah, rich spiced yeast leavened sweet bun that is flavored with saffron and contains dried fruits. Yeah, anyways, I gotta run. So continue having a good Advent, and hopefully you'll have a good Christmas as well when that time rolls around. Hopefully I'll be back again tomorrow, streaming day 14. Maybe I'll stream me trying to figure this out if I just don't figure it out in the car or on my way there or something. But yeah,